Right. So today we'll be discussing relative motion in two dimensions. Okay. Especially there are some cases like relative velocity between a person and rain. Okay. How a boat can cross a river, shortest time possible, shortest path possible. Okay, those cases are what we are going to discuss. Okay. Can one of you quickly tell me the formula for velocity of an object A relative to an object B? This is the basic formula for relative velocity.
VA minus VB, sir.
VA minus VB. Okay. So if you know the individual velocities of two objects, then you can find out their relative velocity using this formula. Fine. Okay. Saket, can you unmute?
Yes.
Okay. Consider this circle. I hope, you may be watching on mobile or laptop, whatever. Keep the screen at rest. Okay. Don't move the screen. So let's say this is an object which is at rest. That means its actual velocity of the circle is 0. Right. All others also, you move to the right, and relative to you, how does the circle move? When you move to the right, relative to you, how does the circle appear to move?
So it stays at rest.
Is it still in front of you? Like at this moment, let's assume it's in front of you. When you move to the right, is the circle still in front of you?
No, sir, it moves to your left.
It moves to the left, right? That's correct. So suppose there is a person, velocity of person. Assume person is moving to the right, rightward direction. Let's take it as positive x direction. Let's say velocity of person is some 2 I cap. Okay, just a rough value. Then velocity of circle with respect to person will be velocity of circle minus velocity of person. So 0 minus 2 I cap, that becomes minus 2 I cap meters per second. Okay, and we all know this. So basically, if an object is at rest and observer is moving towards one side, then relative to the observer, object will appear to move in the opposite direction. Okay, same thing you can experience when you move to the left. Okay, suppose initially the circle is exactly in front of you, and if you shift to the left, then relative to you, the circle will shift to the right. We experience this in daily life. Okay, and that's correct also. Okay. Now consider something like this. Suppose there's an object. Now see, I cannot show you an animation here. It will be difficult. But assume this circle is moving with a velocity 1 meter per second towards right. Okay. Imagine it to be moving to the right. That means when you are at rest, the circle goes to the right like this. Fine. So let's say its velocity is 1 meter per second towards right. So you can write it as velocity of circle is equal to 1 I cap meters per second. Okay. Now, when the circle is going with a speed 1 meter per second or with a velocity 1 meter per second this way, if you also move in the same direction with the same velocity. So if the person's velocity is also 1 I cap meters per second, then one of you quickly tell me what is the velocity of circle with respect to person?
Zero, sir.
It will be 0. Okay, basic formula, velocity of circle minus velocity of person, it becomes 0, and it makes sense. See, it's a circle which is moving to the right. And if the person also moves to the right with the same velocity, then the circle will always be in front of the person. That is why the relative velocity is 0. Means relative to the person, the circle is at the same position, always. It's not moving. Okay, fine. Now assume Or, okay, fine. That is enough visualization. Consider something like this. Let's say there are raindrops falling vertically downward. I'll just copy an image. Just a moment. Consider something like this. Let's say the person is at rest, and to that person, the raindrops appear to be falling vertically downward. Okay, now I want one of you to guess. With what speed do you think raindrops fall on an average? When it rains, with what speed do you think the raindrops would be falling?
Ten meter per second.
Okay. Like, did you read that somewhere, or is it a rough guess?
Yes, yes.
Okay. Can any of you tell me a reasonable way to calculate the speed of raindrops? The speed with which raindrops fall to the ground. What makes raindrops fall?
Gravity, sir.
Gravity. And don't you think you can do calculations, like you can find out the speed attained by an object under gravity? So can any of you tell me an idea to calculate speed with which raindrops fall to the ground? Okay, where do they fall
Sir,
from? Just a
ఎక్కువ
moment.
హైట్ నుంచి పడతాయి కాబట్టి క్యాల్కులేట్ చేయలేము కదా సార్.
మళ్ళీ చెప్పు.
ఎక్కువ హైట్ నుంచి పడతాయి కాబట్టి క్యాల్కులేట్ చేయలేము కదా సార్.
From what height do you think raindrops fall? Rough estimate. Any one of you can answer. She's saying since raindrops fall from a very large height or great height, we cannot calculate their speed using the equations that we derived till now. So I'm asking you, from what height do you think they fall?
100 meters, sir.
100 meters.
1,000 meters, sir.
100 meters is too less actually, because 100 meters is like, see, the other day also we were discussing, each floor of a house roughly is around 3 meters. Okay, so 100 meters means 30 floor building or 33 floor building. I don't think clouds are that low. Sometimes they come down, okay, but usually they are not that low. Someone said 1,000 meters. 1,000 meters would be around 30,000 feet. Reasonable. I'm sure some of you might have gone on flights. Flights usually they fly around that height only, no, around 30,000 feet. They'll be passing. I mean, they'll fly over the clouds. Of course, clouds also will be in layers. Fine. Let's not make it too complicated. Let's take 1,000 meters roughly. It's reasonable only. So let's say raindrops fall from a height of 1,000 meters. Do any of you know the radius of Earth? Some of you, okay, did we ever discuss the radius of Earth? I don't think so. Okay, fine. Radius of Earth is close to 6,400 kilometers. So another 3 zeros, meters, these many meters. So 6,400, 1,000 meters. Okay. Now, what Vanilla said is, since the height is too large, I mean, the height from which raindrops fall, since that height is too large, she is saying we cannot use equations of kinematics, or we can't assume gravity is constant. But see, compared to 6,400 thousands, 1,000 is small, it's negligible. Gravity changes significantly when you go to heights that are comparable with the radius of Earth. Okay, that are significant compared to the radius of Earth. You learn that in the chapter gravitation. Okay, so for 1,000 meters, acceleration due to gravity doesn't change that significantly, it is still, I mean, you can assume it is 10 meter per second square, close to 10 meter per second square. Okay, Vanilla, is it clear?
Yes, sir.
Okay. Raindrops fall from clouds, right? And vertically, they start from rest. So initial velocity of the raindrop is 0. The height by which it falls is 1000 meters. Acceleration due to gravity is 10 meter per second square. So one of you quickly tell me, how do we calculate the speed of an object when it descends by a certain height under gravity? Starting from rest, if anything falls by a height h, how is its speed calculated? Or if you don't remember the formula, tell me which equation of kinematics can be used to calculate. Or aim is to calculate velocity.
Equal to 2s.
V square minus u square is 2s. Okay, that can be done.
So root 2gh.
The formula is root 2gh, which is derived from v square minus u square is 2as itself. I'm using root 2gh here. So it becomes under root 2. G is 10, h is 1000. 10 into 1000, 10,000, 10 power 4. I'll bring it out of the root. It becomes 10 square into root 2. 10 square is 100. Root 2 is 1.4. 414. 100 into that, this becomes 141.4 meters per second. Approximately. So 10 meter per second is 2 less. Okay, one of you had guessed 10 meter per second. That is 2 less. But now tell me, is this value, I mean, is this calculation correct in real life? Valid in real life? Suppose a raindrop is actually falling from 1000 meters. Will it land with this speed in real life?
No,
Why not?
air resistance.
Because of air resistance, correct. Okay. And since raindrops are very small, I mean, they are not heavy objects, right? Air resistance will show significant effect on them. It will have significant effect. Okay. Anyway, see, this is just to show that rough calculation, rough estimate can be made. But if you include air resistance, then there will be a significant change in the answer. Let it be. So let's say raindrops are falling with a speed of, let's say they are falling vertically down. There's no wind or anything on that particular day. They are falling vertically down with a speed 20 meters per second. Okay, that's the velocity of rain. Okay, can one of you tell me how to write this velocity as a vector in terms of I cap, j cap?
Minus 20 j cap, sir.
20 in the downward direction, so minus 20 j cap. So can be written as VR is equal to minus 20 j cap meters per second. Fine. Now, if the person is at rest, raindrops will appear to fall like this itself. That's okay. See, some of you may have studied this already. Those who have studied, don't answer. Others try. If the person walks or runs to the right, okay, or they may even drive, okay, you imagine they are inside a vehicle or whatever it is, then how will the raindrops appear to fall? Means, will they still appear to fall vertically downward, or relatively will they appear to be moving in a different way? That's the question. First, tell me, see, raindrops have a certain velocity. Okay, raindrop you consider as one object. Person is another object. Okay. Now, if person's velocity changes, will the relative velocity change or not? Generally, if one object's velocity changes, will the relative velocity of another object change or not?
Yes, sir.
It has to change because generally velocity of A relative to B, whatever A and B are, is velocity of A minus velocity of B. If one of these changes, then this will definitely change. If both VA and VB change, then relative velocity may still be the same. But if only one of them changes, then the relative velocity will definitely change. Are you all convinced with this or not? Generally, if x is equal to y minus z, if only y changes, then x value will definitely change. Is this idea clear to all of you? Any question in this? Okay. So raindrops are falling vertically downward. And when the person is at rest, that is how they appear to fall. But if the person moves, will they still appear to fall in the same manner or will there be some change? That is the question. What do you say? Will the raindrops appear to fall differently or will they still appear to fall vertically downward to that person if the person starts moving? Okay, you all imagine this. Okay, I didn't get any answer from any of you. Consider the circle again. Imagine that itself is a raindrop, whatever. Now you can see at one instant it is at that position. I hope you all are at rest in front of your screen. What I will do is I will move this object downwards, step by step like this. Fine. I'm moving it vertically downward. And if you are at rest, your screen is at rest, like then it will appear to be moving downward only to you also. Okay. Now you all do one thing. I will keep moving this object downward. Okay, I'll keep moving the circle downward, but you move to the right side. Okay, you don't have to actually stand and walk, but just move your head to the right side. Will the circle still appear only to be moving vertically downward, or does it have a horizontal movement also now? When you move to the right, is it still in front of you, or did it go to the left, or did it go to the right? Respond. How does it appear to be moving? Relative to you, not relative to your screen or table or anything. Okay, Yusuf, can you unmute?
Yes, sir.
So what I'm going to do is, just a moment. I'm going to make this object move vertically down on a straight line. I'll make it move on this straight line. Okay. Now the straight line is vertical relative to your screen. So at one position, the object will be here. At one instant, the object will be here. Next instant, it will be here. Another instant, it will be here. Another instant, it will be here. Another instant, it will be here. Okay. I'm going to move it that way. As the object moves along A, B, C, D, E, you move to the right side and you have to tell me how the object appears to move as seen by you.
Sir, looks like it's against me. Like, from my
Okay, just
right
a
to
moment.
left.
I don't know why, but your voices are too low today. Can you repeat what you said?
So it looks like it's against me, sir. It goes from my right to my left as I move to my right.
Okay, when you move to the right, it appears to go to the left a little bit. Does it also appear to be coming down or not when I take
Yes,
it
sir.
from this? So it seems to be coming down and also moving to the left.
Yes.
Okay, obviously, when you move to the right, the circle would have shifted to the left also. Fine. Do all of you agree with this? Any confusion in this? Okay. So see what is happening here is person is moving to the right. Okay. Let us assign some velocity to that person. Let's say some 4 meters per second. Assume velocity of person is 4 I cap meters per second, and velocity of raindrop we already know it is minus 20 J cap meters per second. Now the person is observing that raindrop which is falling downwards. Raindrop is falling downwards with respect to ground. Okay. Now, if the person moves, then relative to person, the velocity of the raindrop will be velocity of person minus velocity of raindrop. Okay, VPR. Fine. Just a moment, I have to change this. Velocity of raindrop with respect to person is what we want. So VRP. Rain with respect to person. So it will be velocity of rain minus velocity of person. Velocity of rain is minus 20 J cap minus velocity of person is 4 I cap. Therefore, velocity of raindrop with respect to person will be minus 4 I cap minus 20 J cap. Okay. Now minus 4 I cap minus 20 J cap would look like this. Minus 4 I cap minus 20 J cap. This is how the raindrops appear to fall as seen by the person. Now, I am sure most of you would have experienced this also while moving in a car or a train when it is raining. Okay. When the car is at rest, we are assuming there is no wind blowing. When the car is at rest, raindrops will appear to fall vertically downward. You can see out of the window and notice that. But when the car moves forward and you look out from the window, the raindrops appear to be falling at an angle, okay, tilted backward. When the car moves forward, the raindrops appear to tilt backward. Have you all noticed this or not? How many of you have ever observed this in real life? How raindrops appear to fall when you see from a moving vehicle, car or train?
Yes, sir, observe, sir.
Yusuf has observed. Others have never seen anything like that. Okay. Fine. Anyway, these days it is rainy season only. Try to observe that sometime. Okay, that is true. Fine. When you are moving forward, relatively, they'll appear to move backward. Now they are actually moving vertically downward. They are falling vertically downward, but they'll get that relative horizontal velocity in the backward direction. So they'll appear to fall at an angle like this. So when the person starts moving, just a moment, I'll show you on diagram. Okay, when the person moves to the right, this is how the raindrops appear to fall. Actually, they were falling vertically downward. I'll copy that diagram also. Where is it? Okay. So first case, person was at rest. Second case, person is, let's say, walking with some speed, say some 4 meters per second. Then this diagram is the relative velocity diagram, not the actual velocity of raindrops. With respect to person, how it appears is what we are showing here. So this is the velocity of rain with respect to person now. Okay. Now one of you tell me, if the person walks or runs faster, how will the raindrops appear to fall? In the same direction, if the person walks or runs faster, how will the raindrops appear to fall? Will it be same as the first diagram, same as the second diagram, or will there be some more change?
There'll be change.
Which way? What is going to happen?
So he's gonna get more water on him.
That is okay. How do they appear to fall? How do the drops appear to fall? That's what we are considering.
Directly against him, almost directly against his face.
Okay, so you are saying they'll be making more angle, almost hitting the
Yes.
face from right in front. Okay, that's correct. Are you all convinced with this or not? Others? If the person starts walking faster, okay, you can do the simple calculation also. Here we took person's speed as 4 in that rightward direction. Let's say person's velocity changes to some 6 I cap or 8 I cap. Then what will happen? Velocity of rain minus velocity of person. This will become minus 8 I cap. Okay. minus 8 I cap minus 20 j. Minus 8 is a longer vector like this, and minus 20 will be this way. Then it will fall at a greater angle like this. Okay, it will tilt more relatively. So situation would be somewhat like this. These are all relative cases only, not with respect to ground. With respect to person, this is how what it appears like. So let's say person is now moving with a speed some greater amount of speed, 8 meters per second. Okay. So actual velocity of raindrops is vertically downward. When person is at rest, they'll appear to fall vertically downward only. Okay. But when person moves forward with some speed, then velocity of rain with respect to person will be at an angle like this. Okay. When the person moves forward with an even greater speed, then the velocity of rain with respect to person will be at a greater angle like this. This is also relative only. Fine. And the calculation also tells us the same thing. Okay. So depending on how the person is moving, how the rain appears to fall changes. So you'll have to know how to answer questions based on all this. Like depending on the person's speed, at what angle the rain appears to fall, at what angle the person needs to hold the umbrella to protect himself or herself. Okay. Or at what angle the person needs to move such that rain appears to fall at a particular angle. At what speed the person needs to move such that rain appears to fall at a particular angle. Such questions you need to know how to answer. But remember the basics. I mean, visualization is very important, as I said. What was actually happening here? Raindrops were falling vertically downward. Okay. We took that case. We took that as the actual velocity of rain. Now you all tell me from everyday experience, is it compulsory that raindrops always fall vertically downward?
No, sir.
No. If wind blows, rain can, like naturally itself, raindrops can fall at an angle. Okay. So that will be given to you in the question, how the raindrops are actually falling, or sometimes you may be asked to find out how they are actually falling. But remember the general idea. In case raindrops are falling vertically downward like this, if person moves to the right, then relatively raindrops will appear to tilt to the left this way. And the opposite also will happen. If the person moves to the left, then relatively raindrops will appear to tilt to the right with respect to the person. Okay. And as we just discussed, it's not necessary that raindrops always fall vertically downward. Okay. Suppose due to wind or something, the raindrops are actually falling with a velocity like this, at an angle like this. Then, okay, so let's say when person is at rest, they appear to fall like this. Now, if person moves to the right, if the velocity of person is to the right, then velocity of rain with respect to person is velocity of rain minus velocity of person, right? Now, actual velocity of rain is like this. Velocity of person is to the right, then minus velocity of person will be to the left. Then they will relatively appear to fall like this. Okay. But still, the idea is the same. If person moves to the right, this vector tilts to the left. Suppose person moves much faster to the right. Okay. Velocity of rain, actual velocity of rain is like this only. But suppose the person has a large velocity to the right. Then minus velocity of person. This is VR, velocity of rain. Then and this is minus velocity of person. Then relatively they can appear to fall at, they can appear to fall at an angle in this direction also. So how rain appears to fall depends on, okay. Okay, is my screen visible to all of you?
Yes, sir.
Right. So yeah, see, not just in case of person and rain, generally, if A moves in one direction, then relatively B's velocity will tilt in the opposite direction. I'm not saying B will absolutely move in the opposite direction, but its velocity has to tilt in the opposite direction. So what we are actually using here, velocity of rain with respect to person, is velocity of rain minus velocity of person. So if person's velocity is forward, then negative of velocity of person will be in the backward direction. That is what makes rain's velocity vector tilt in the backward direction. Reverse. If person is moving to the left, then negative of velocity of person will be to the right. Then rain velocity will tilt towards right. The vector will tilt towards right. Okay. Is the idea clear to all of you? Why raindrops appear to fall at an angle? Any question in this? Okay, just a moment. I'll switch my network back to Wi-Fi. Is my voice also clear?
Yes, sir.
Okay. Still, just a moment. Right. Fine then. Try to answer some questions, all of you. First, raindrop. Okay. So let's say raindrops are falling vertically with a speed 20 meters per second, and person, let's say, is moving towards east. With a speed, how much shall we take? Let's say 4 meters per second itself. Okay. So first question, calculate the angle with vertical at which the drops appear to fall. Next part, calculate the speed with which they appear to fall relative to the person. Okay. I want you all to draw the vector diagram first. What do you mean by vector diagram? Draw a vector indicating the velocity of rain. Draw a vector indicating the velocity of person. Then draw the vector indicating velocity of rain with respect to person also. Okay. After that, you do the calculations. Okay, I'll give you all 2 minutes to do this. Make it fast. Okay. Let us draw the vectors first. Velocity of rain as given in the question is vertically down. So assume this vector represents the velocity of raindrops. Its magnitude is 20 meters per second. Person as given in the question is moving to the east. Let's assume this direction, the rightward direction is east. Person is moving with a speed of 4 meters per second. So velocity of person would be this way. If you write them as vectors, this will be 4 I cap. Rain velocity will be minus 20 j cap. Okay, meters per second. Fine. Now, in the question, you are asked how the rain appears to fall relative to the person. So it's the relative velocity that we need. Velocity of person with velocity of rain with respect to person is what we are interested in. So velocity of rain with respect to person, basic calculation, velocity of rain minus velocity of person. Okay. Now velocity of person is to the right, 4 I cap, then negative of velocity of person. Now why am I taking negative every time? Simple. Well, VR minus VP becomes VR plus negative of VP. That's the idea we are using. Subtracting two vectors means adding the first vector to the negative of the second vector. Okay, that is what we are doing. So negative of velocity of person would be to the left like this. Fine. Now we need to do VR minus VP. VR is this vector. I'll take it as it is. Minus VP is this vector. I'll place it here. So VR minus VP will be the sum of these two vectors, which you can clearly visualize. Now tell me, how should I draw the resultant of these two vectors? Should I use triangle law of vector addition or parallelogram law of vector addition when they are placed like this? When vectors are arranged like this, with the head of one at the tail of the other, should I draw their resultant using triangle law or parallelogram law?
Triangle law, sir.
Triangle law should be used. Okay, the resultant is given by the closing side of the triangle taken in reverse order. So this is the velocity of rain with respect to person. So when the person is moving towards east, the raindrops will appear to be tilted, okay, falling at an angle tilted towards west. Opposite direction is west. Okay. So this is how they appear to be falling as seen by the person. Now what are you asked in the question? The angle at which the raindrops appear to fall and the speed with which they appear to fall. Angle is this angle. Now they have to mention in the question whether they want angle with the vertical direction or with the horizontal direction. Usually in case of raindrops, it is taken with the vertical. Let's call this angle as alpha. We have to find out how much that angle is. And we should find out the speed with which they appear to fall, relative speed. Can any of you tell me how relative speed is calculated? How is relative speed calculated?
Magnitude of relative velocity, sir.
Correct. Okay. You have to find out the relative velocity and then take its magnitude. Okay. Then why did you send answer for speed as a vector? Anyway.
I thought velocity, sir.
Okay. Okay. Fine. Yusuf, tell me, how will you express this angle alpha? Or Aishwarya, you tell me, how will you express this angle alpha?
For tan alpha.
You can use tan. Okay. Negative of velocity of person, its magnitude is 4. Velocity of raindrops, its magnitude is 20. So it's like this side is 4 units, this side is 20 units. Opposite adjacent, you can use tan alpha. 4 by 20, that is 1 by 5. So the angle with the vertical at which the raindrops appear to fall will be tan inverse of 1 by 5. Simple. Next is relative speed at which they appear to fall. Relative speed is magnitude of relative velocity. Let's write relative velocity first. That will be minus 4 I cap minus 20 j cap meters per second. Then speed of the raindrops with respect to person will be square root of this. Simple. That's how you take the magnitude of a vector. 400 plus 16 root of 416. We'll leave it at that. Fine. Now tell me, root of 416 is more than 20 or less than 20? Is square root 416 greater than 20 or less than 20?
Greater than 20, sir.
Greater than 20. Actually, the raindrops are falling with a speed 20 meters per second. But because the person is moving, they appear to fall at a speed greater than 20. So that is possible. I'm not saying they'll always appear to fall at a speed more than the actual speed, but that's a possibility. Okay. So depending on how the observer is moving, the raindrops, their speed may change. The angle at which they fall also may change relatively. Okay. Let's consider another case. Assume raindrops are falling at an angle 37 degrees due to wind or something. Due to wind only. They are falling at an angle 37 degrees with the vertical like this. So this is the actual velocity of rain. How much shall we take? Let's take 20 meters per second itself. They're falling at an angle like this, 37 degrees. Now, first you all use your imagination and tell me, if the person moves to the right, okay, person is moving on a horizontal road, let's say towards right. If the person moves to the right, how will the raindrops appear to fall? Means, will they appear to fall at the same angle 37? Will they tilt further to the left and the angle becomes more than 37? Or will they tilt to the right and the angle becomes less than 37? What do you think will happen if the person is moving to the right? You have to imagine velocity of rain with respect to person.
The angle will become more, sir.
Okay, so you are saying it will tilt to the left, further to the left. Others, Aishwarya, what do you say?
Sir, it will tilt more towards the left.
Okay. Yusuf, what do you think? No response. Pawan?
Sir, angle increases.
Okay, fine. What you all said is correct only. So what you need to visualize is velocity of rain with respect to person, which is velocity of rain minus velocity of person. Okay, let us copy these vectors as it is. This is the actual velocity of rain. Put it here. Minus velocity of person means plus negative of velocity of person. So I'll take the negative of this vector and add it to that. See, this visualization should be done. Now see, some of you are very good at using formulas and getting answers correct. But you are preparing for entrance exam, they may not ask the usual questions. Usual questions can be solved using formulas. Okay? But if something other than usual, or if they want to test something extra, then all this visualization, application of the basics should be known to you. So velocity of rain minus velocity of person. So now the raindrops appear to fall like this. Okay, and clearly the angle at which they appear to fall now is greater than the original angle at which they were falling. That possibility is there. It can become 38, 39, 39.96, whatever it is, 45, 57, 53. It could become any angle depending on how the person moves. Okay. Fine. Take one question based on this. Let's say speed of the person is let's use some practical values. Okay, 3 meters per second. Same thing that you found in the last question. Find out the angle at which the raindrops appear to fall and the speed with which they appear to fall. You have to find out the angle at which the the raindrops appear to fall, means this angle with the vertical only, and the relative speed with which they appear to fall. Yeah, Vanilla, any doubt?
Yeah, should we first find out its components, so like x component and y component?
Without finding components, will you be able to find the resultant?
No, sir.
Then make use of components. See, you can use any valid technique. So if you think components are necessary to answer, you take component. It can be done without taking components also. I'll explain it both ways, but you do it like that. No, actually taking components will be easier. I mean, if you take components, the solution will be easier. Okay, I got only one answer. Fine. Listen, all of you. You are asked to find out the angle at which the raindrops appear to fall. So indirectly, what you are asked to calculate is the angle made by the relative velocity vector. That's all. So you first get the relative velocity vector, then find out the angle that it makes. Okay, let us go step by step. Aishwarya, tell me, did you express the vectors in terms of components?
So yes, sir.
Okay, how do you write this velocity of rain in terms of I cap, j cap?
So -3 I cap, -20 J cap.
How is it -3 I cap, -20 j cap? No. I think you included this also and you are telling relative velocity. I'm just asking you what is the range velocity in terms of I cap, j cap? This is not -20 j cap anymore. -20 j cap would be like this, no? It's at an angle, it's not in the y direction. Okay, this vector is not in the y direction. Okay, anyone, can you tell me, or okay, do this all of you. Express this vector in terms of I cap, j cap. How much is its, sorry, how much is its y component? Y component would be like this. And how much is its x component? X component would be like this. The rain velocity itself has y and x components now. It's not vertical. Or if you are more comfortable with this, you can imagine the x component here also. Pawan, how to calculate component of a vector in a particular direction?
Sir, u cos theta.
Okay, you have to make use of the vector's actual magnitude and the angle it makes with that direction. Now see, the rain's actual speed is 20. Okay, that's the magnitude of that VR vector. Now we need its components in two different directions. Let's take the y component first, this one. If you want y component, you need to consider the angle made with the y axis. It's clearly making 37 degrees with the y axis. So its component in this direction will be 20 cos 37 degrees. Cos 37, 4 by 5, 20 into 4 by 5 becomes 16 units. Aishwarya, is this clear?
So yes, sir.
Huh. Can you tell me its x component? If this angle is 37, the angle with the x-axis will be 53 degrees. How much is the other component?
So 12 J cap.
Don't say j cap. J cap is positive y direction. Is that in the positive y direction?
Negative I cap, negative 12 I cap.
Ha. Its magnitude will be 12. 20 cos 53. 20 into 3 by 5 becomes 12. This is minus 12 I cap. And this 16 actually can be written as minus 16 j cap. Therefore, in this case, the rain's velocity itself is minus 12 I cap minus 16 j cap meters per second. Okay, we still didn't calculate relative velocity. The rain velocity itself is this much. And the person velocity you can write directly. Since it is to the right, it's easy to express 3 I cap meters per second. Okay. Vanilla, you tell me, what is the velocity of rain with respect to person as a vector?
Minus 15 I cap, minus 16 J caps.
Okay. It's just velocity of rain minus velocity of person. VR minus VP, if you subtract that, it becomes minus 15 I cap minus 16 J cap meters per second. Let it be. And now you can tell its magnitude. That will be the relative speed. And if you want direction, Imagine this vector. If you want the angle, imagine this vector. Minus 15 I cap, minus 16 J cap. So this is how the raindrops actually appear to fall. And if you want the angle that they make with the vertical, call this angle as alpha. If that angle is alpha, this will also be alpha. Tan alpha, opposite is 15, adjacent is 16. Tan alpha is 15 by 16. Or alpha is tan inverse 15 by 16. That's the angle at which they appear to fall with the vertical. Okay. Hope the steps are clear to all of you. You could have done it using this vector diagram also. See, actual velocity of rain is 20, no? Just a moment. Observe the diagram on the right side. Actual velocity of rain is 20. Velocity of person is 3. Negative of that, its magnitude will be 3 itself. This is 3. Let it be. Now that 20, it has 2 components. Okay, I'll draw those components in green. That 3 is actually not to scale. Okay, if that blue vector is 20, that orange vector cannot be 3. It's not to scale. But 20's x component was 15. 20's y component was 16. Now what you want is that black vector. That's the velocity of rain with respect to person. That black one is what we want. The black one, if you observe, its y component is this much, 16 units downwards. Its x component is this much. Okay, wait, sorry. How did that become 15? This is 12. The x component of 20 is 12. Okay, we had calculated that. So that black vector's x component will be this 12 plus 3, 15. So this way also you can answer. That vector is minus 15 I cap, minus 16 J cap. You will have to take components. Okay. And if you want the angle now, you can call this angle as alpha. Tan alpha will be this side is 15, this side is 16. Tan alpha is 15 by 16. Okay. See, some of you seem to be doing this for the first time, or like you are relatively slow in this. Not an issue. With practice, you will become like very comfortable with all this. Don't worry. So is this solution clear to all of you? Any questions in this? You were given how the raindrops were falling. You were given how the person is moving. You are asked relatively how they appear to fall. Speed and angle. Okay. Now see, person moved to the right. So relatively the rain velocity appeared to tilt to the left. Makes sense. Now think about the reverse, like the other case. If person moves to the left, relative velocity of raindrops will tilt to the right, and tilting to the right means they may tilt a little bit like this, or they may tilt sufficient enough to become vertical like this also. So if a person moves with a particular velocity, the raindrops can appear to fall vertically to that person. Okay, they're not actually falling vertically, but there is one way in which they can appear to fall vertically to that person. Okay, let us find that out, how it is possible. So another question based on the same situation. Let's say raindrops are falling like this. Okay, these are its components, let it be. This component was 16 in the downward direction. This was 12 towards left. That's the actual velocity of rain. And we know if the person moves to the left, raindrop velocity can tilt to the right. And tilting to the right, it can become vertical at some point. So the question is, to find out with what speed the person should move to the left. Such that the raindrops appear to fall vertical. Try this, all of you. And listen to this idea, all of you. Raindrops should appear to fall vertically means mathematically velocity of rain with respect to person should only have a y component. It should not have an x component. Okay, it should be only in the y direction. So velocity of rain with respect to person must have only y component. That's the mathematical what can you say, logic that you have to use here. Vanilla, your answer is correct only. Okay, Pawan, your answer is also correct. Okay, listen, all of you. We'll visualize first and then solve. So this is the actual velocity of raindrops. We know the angle and all, let it be. Now we want to find out the person's velocity such that the raindrops appear to fall vertically. Now let's take the first case. Assume person moves to the left with a small velocity. So this is velocity of person. This is velocity of rain, you can see. And velocity of rain with respect to person is velocity of rain minus velocity of person. Okay. Now velocity of rain, you know the vector. Now if velocity of person is to the left, minus velocity of person will be to the right. And we are assuming, one case we are assuming that the velocity of person is very less. Then what will happen? Relatively, the raindrops still appear to be falling tilted to the left like this. Okay, or maybe I'll show it in orange itself. Corresponding to that case of person's velocity, the raindrops appear to fall like this. They have tilted to the right, but they are not vertical yet. They still don't appear to be falling vertically. Okay. Next case. Suppose the person's velocity increases a little bit, or let's say the person moves with a slightly greater velocity to the right. Then negative of velocity of person will be slightly, sorry, person is moving to the left. Negative of velocity of person will be to the right this way. But if it's not sufficient, the raindrops will still appear to be falling at some angle like this. Another case, the one last case we will assume. Suppose the person moves with even greater velocity to the left. Then negative of person's velocity will be to the right. And for one particular value of that person's velocity, the relative velocity of raindrops will be vertical like this. Velocity of rain with respect to person. That is velocity of rain. This is minus velocity of person. And that is the relative velocity. And this is the case we are looking for. Okay, see, this kind of visualization is important. Person moves with a small velocity to the left. Raindrops tilt only a little bit towards right. Person moves with a slightly greater velocity towards left. Raindrops tilt a little further towards right, but may not be vertical yet. Okay, so there will be one velocity of person to the left for which the raindrops will tilt to the right and become vertical relatively. Okay, is this clear to all of you? Are you all able to visualize this? If you have any doubts, you ask. Okay. So this is the case we are looking for. Fine. Now there are two ways to solve this. You can solve it using this vector diagram itself, or you can write equations and solve it mathematically. Let us do it both ways. Now that vector velocity of rain, it had components. Its x component was 12 and its y component was 16. Now what we want is VR minus VP should only have that y component. It should not have an x component. Means the x component of VR, this one, should be cancelled by the x component of VP, this one. Then only the y component will survive. Okay. For that, how much should VP be? 12 units. So the person should move to the left with a speed of 12 meters per second, such that the velocity of, such that the raindrops appear to fall vertically downwards. Okay. Now, at the beginning of this class, we took one situation. We imagined one situation with that circle. Yeah. If the circle moves to the right with a speed 1 meter per second, and we also move to the right with a speed 1 meter per second, relatively the circle will be at rest. Relatively, the circle won't move to the right because it will always be in front of us horizontally. That is what is happening here now. The raindrops are falling at an angle. Okay. Their horizontal velocity was 12 meter per second to the left. Okay. This is the raindrops horizontal velocity. If the person also maintains that velocity to the left, then relatively raindrops won't move to the left or right. Horizontally, they won't move. They'll only be moving vertically. That vertical velocity will anyway be there. Okay, that is what we found out here. So basically, the horizontal velocity of rain must get cancelled. So whatever is the horizontal velocity of rain, person also should move with the same horizontal velocity, such that relatively horizontal velocity becomes 0. Only vertical velocity will be there. Now, how to do this mathematically? Let us discuss that also. We know the velocity of rain is minus 12 I cap minus 16 j cap meters per second. We don't know the velocity of person. One thing we know is that person should move to the left. Left is minus I cap direction. So I'll take velocity of the person as minus V I cap. Sometimes you may not know that also, which way the person should move. So you can simply write it as V I cap also, not an issue. Okay. V could be a positive value. V could be a negative value depending on whether person has to move to the right or to the left. Let us take it generally like this. So velocity of rain was given in the question. Person either goes to the right or goes to the left. Person is walking on a horizontal surface. Okay. So we took it as Vi cap. It could be, V could be a positive number if person is going to the right. V could be a negative number if person is going to the left. V will be a negative number if person is going to the left. Now combine these two and write velocity of rain with respect to person, which is velocity of rain minus velocity of person. Aishwarya, can you tell me this vector in terms of I cap, j cap?
So minus 12 minus V I cap minus 16 J cap.
Minus 12 minus V I cap minus 16 j cap. Correct. Now apply the condition given in the question. The condition given in the question is that relatively rain must appear to fall vertically. Means rain should not have a horizontal component. This should become 0. When will this be 0? Minus 12 minus V is equal to 0. That means V is equal to minus 12. That's all. Therefore, velocity of the person becomes minus 12 I cap meters per second. We are getting the answer along with the direction. This is how you solve it mathematically. Okay. Hope this is clear to all of you. Raindrops were actually falling slightly tilted to the left. How should the person move such that that tilt is not visible? They have to they should appear to fall vertically. That means their horizontal velocity should get cancelled. So whatever is the horizontal velocity of rain, person also has to move with the same horizontal velocity such that relative horizontal velocity becomes 0 and relative velocity will be there only in the vertical direction. Based on that, we wrote the condition mathematically and found out the velocity. See, there are many other things that can be asked in this situation. I'll send you a worksheet tomorrow. Like here, we made the raindrops appear to fall vertically. I mean, we found the condition under which they appear to fall vertically. They may ask you a question like this. How should the person move such that raindrops appear to fall at an angle 37 degrees on the other side, or at an angle 45 degrees on the other side, or their actual velocity was 20? They may ask you, how should the person move such that rain appears to fall with a speed 30 meters per second relatively? So they can ask you questions based on relative speed. They can ask you questions based on angle, relative angle. Okay. And you should be able to answer every question like that. And it's quite easy. It just takes a little bit of practice. Initially, you'll have to patiently draw the vector diagrams, take the components and then calculate. But once you solve 5-6 questions, you'll get used to it. Okay. And next class, I will take tomorrow itself because we are going a little slow. Okay, there's another case of relative velocity in 2D that we have to discuss, river boat problems. Those things we'll be discussing tomorrow. Okay. Will you all be able to attend class tomorrow? It will be from 7 to 8 or 8:30. Will you be able to attend? Or you tell if we can start earlier. Can I start at 6:30?
Yes, sir.
Aishwarya, Vanilla, Yusuf, can we start the class at 6:30 only for tomorrow?
Yes, sir.
Okay. Okay, Yusuf has some other class. Yusuf, till when do you have that class tomorrow?
So 8 o'clock or 7:30?
I didn't understand. 8 o'clock?
So it might be till 8 o'clock or 7:30.
Okay, till 7:30 or 8. Okay, then we'll have the class at that time. Shall we start the class at 8 o'clock?
Yes, sir.
Fine. So 8 to 9 or till 9:15. Others, is it okay?
Yes, sir.
Okay, fine. Actually, by this time, we should have completed this chapter and started laws of motion also. Just a little bit is left. Okay, then. So tomorrow class will be from 8 o'clock. And I'll send you a worksheet based on what we discussed in the last class. Also, I prepared the worksheet, but I think I didn't send. Anyway, I'll send you that and one based on relative velocity also. Practice these questions. These are very common and they'll ask you these questions quite frequently in entrance exams. Okay. And next case will be even more interesting, riverboat problems. Fine, we'll continue tomorrow. Thank you all.